It's one small step for man, one giant leap for mankind.
Every bold step forward faces barriers. And with each hard-earned advancement, we come to expect more from life. Because innovations grow our world. They change how we live and what we can make possible. Life is now lived always on and on demand, where wants big and small are fulfilled with just a tap or an ask. So then, what's now possible? Mobile commerce, autonomous driving, next-gen wireless, smart appliances, industrial automation, all made possible by NXP. We are the gateway to the responsive interactions that are redefining life as we know it. NXP expands the possibilities for technology producers around the globe. From seamlessly integrating infrastructure to effortlessly streamlining data from the cloud to the edge, we bring what's next closer. We're not only advancing technology, we're advancing how we live. This is NXP.
It's one small step for man, one giant leap for mankind.
Every bold step forward faces barriers. And with each hard-earned advancement, we come to expect more from life. Because innovations grow our world. They change how we live and what we can make possible. Life is now lived always on and on demand, where wants big and small are fulfilled with just a tap or an ask. So then, what's now possible? Mobile commerce, autonomous driving, next-gen wireless, smart appliances, industrial automation, all made possible by NXP. We are the gateway to the responsive interactions that are redefining life as we know it. NXP expands the possibilities for technology producers around the globe. From seamlessly integrating infrastructure to effortlessly streamlining data from the cloud to the edge, we bring what's next closer. We're not only advancing technology, we're advancing how we live. This is NXP.
Thank you for joining us at NXP Semiconductors. My name is Gavin Smith, and I'm a marketing manager for the Radio Power business line at NXP. Today, I'd like to welcome you to the NXP RF GaN Fab Grand Opening Ceremony. You will hear from NXP executives, government officials, and industry experts. We'll be going over what makes this GaN Fab special. We'll also look at how GaN technology is impacting certain markets, like cellular infrastructure and 5G. Then we'll go into virtual sessions, and you will hear from NXP applications engineers, designers, and other team members associated with the GaN products that we produce. With that, I'd like to introduce Kurt Sievers, NXP CEO, for the opening keynote. Thanks for tuning in, and I hope you enjoy.
Thank you for the opportunity to address you all on this most momentous occasion. And of course, I wish we could all physically be together here in sunny Arizona on this special day. But I do hope you're all staying safe during these unprecedented times. Good morning, good afternoon, good evening to you, depending on where you are in the world today. I'm truly honored to address you, and it is my privilege to welcome you to the virtual grand opening of our new RF gallium nitride factory, and thank you all for joining us here and today. I especially wish a very warm welcome to our US federal, state, and local government representatives with us today, including US Commerce Deputy Undersecretary for International Trade, Joseph SEMSAR, the Arizona Governor, Doug Ducey, the Arizona Senator Kyrsten Sinema, the Arizona Senator Martha McSally, and the Ambassador of the Kingdom of the Netherlands to the United States, Andre Haspels. And last but certainly not least, the City of Chandler Mayor, Kevin HARTKE. Welcome all. Our strategy and investment in action. You know, this is a momentous occasion. And it is momentous because we have built from scratch our own manufacturing facility here in beautiful Chandler, Arizona, for gallium nitride. And this is such a critical milestone for the next generation of 5G base station infrastructures. By building this incredible facility and investing in technology and key talent in Arizona, we are able now to bring focus on gallium nitride technology for vital communications systems. I am so touched by how hard our teams have worked to get this GaN fab, which we can now release into production, up and running. And that was not a small feat during the COVID-19 period. Our priority at NXP is to serve our customers with high-quality gallium nitride device production. During the virtual tour that you will all have in a few minutes, we'll showcase you our key capabilities. You will clearly see that our investment in this technology and in the facility speaks to the critical nature and the utmost importance we see in GaN technology serving the market into the next many years. And we've had a long history of R&D leadership. The journey to get here, as you may know, hasn't exactly been short. NXP first started developing GaN technology nearly 20 years ago, moving international development to foundries and labs later in the decade. After 5G became an imminent reality, it became clear to us that 5G applications would be so much better served by gallium nitride in RF amplifiers serving them. So more recently, with the emergence of 5G cellular infrastructure and its higher power and operational frequency requirements, gallium nitride power transistors have begun to emerge as the new potential gold standard for cellular base station transmitters. This is very, very important to NXP and specifically many of our key customers and distributors. Take as an example Ericsson, whom we have worked with for many, many years. For them, gallium nitride is vital for their future roadmap. Our leadership and deep wireless communication industry knowledge positions us very, very well to be an instrumental partner to deliver 5G infrastructure well into the future, and now it's under our own roof right here in Chandler, Arizona. This is a huge milestone for the company and very, very important to our customers when we will start shipping just a little bit later this year. At NXP, we want to help build the secure connections for a smarter world. I believe that with the creation of this great facility, we are not only advancing the industry, but also in a larger sense, advancing society. And that is something to be proud of. I am personally proud of it. And now let me hand over to Paul Hart, our General Manager for the Radio Power business line at NXP. And Paul, congratulations to you and the team here in Chandler for this awesome accomplishment. Thank you and enjoy the rest of this event. Thank you.
Thank you, Kurt, for the kind words, and thanks to all who are joining us today from around the world. It is truly a proud day for NXP and a proud day for me personally. as we unveil our new 150mm RF GaN fab in Chandler, Arizona. As Kurt stated, today is a culmination of over 17 years of research and investment in gallium nitride by NXP, along with over 3 years of intense activity to convert this site into what we believe is the most advanced facility for RF gallium nitride manufacturing in the world. During the virtual tour that we will have for you in a moment, we'll be highlighting our key capabilities for gallium nitride manufacturing and showcasing how this facility will be the hub for the next generation of 5G for cellular infrastructure. GaN is the technology of the future, a leading-edge semiconductor technology critical to building advanced 5G communication systems. GaN's unique characteristics can deliver significant increases in power efficiency and transmitted power while simultaneously enabling considerable size reductions for 5G radio systems. Further, the high-frequency capability of gallium nitride means that it will enable future wireless communication standards requiring even higher bandwidth and operating frequencies. It was with this vision in mind that we configured this facility to directly scale from 5G to 6G and beyond. What's most exciting for me is the fact that this fab here in Chandler is a highly visible demonstration of NXP's commitment to this technology and to the communications infrastructure market. However, as Kurt touched on, that commitment is not new. For many years, NXP has been actively engaged in GaN technology development and refining the associated manufacturing processes. Our work on GaN first began back in the Motorola era. It was in Motorola Labs in Phoenix, Arizona on a 2-inch silicon carbide substrate where our first efforts into gallium nitride manufacturing began. Our GaN technology investment has continued ever since, moving from the internal labs out to foundry partners over time. In 2014, NXP launched our first commercial GaN RF power transistor product, and we've been expanding our product portfolio ever since. When it became clear that GaN was going to be a key technology for 5G, we invested to build out our own manufacturing line. We looked across all of our sites at our talent pool to see where there was expertise in compound semiconductor manufacturing, and found that the key team with the right skill set existed here in Chandler. Additionally, with the proximity of the GaN fab to NXP's radio power group, also in Chandler, our engineers can more rapidly develop, implement, and validate the inventions and new product concepts that will allow NXP to continue to lead in the RF power market through the 5G era. With GaN transistors poised to take a front seat in cellular infrastructure deployments, we have accelerated our GaN technology roadmap, and along with it, our pursuit of IP creation and protection for the rapid innovations in 5G. We are pleased to be sharing this significant achievement with all of you. This new fab, coupled with NXP's 25 years of industry-leading expertise in the high-power RF domain, spanning technology and product development to radio system know-how, and perhaps most importantly, high-volume, high-quality manufacturing, put NXP in a prime position to continue to lead in 5G. In closing, I'd like to thank the NXP operations and facilities teams for the build-out and bring-up of this facility, the NXP technologists for their decades-long pursuit of perfection in gallium nitride, the radio power product development teams for the creation of industry-leading 5G products, and most importantly, our customers for the support and partnership you've offered along the way. After years of planning, blood, sweat, and a few tears, we have created something unique and industry-leading, a job well done to all involved. And now I'd like to introduce our City of Chandler Mayor, Kevin HARTKE. Thank you and enjoy the rest of the event.
Thank you, Paul. It's exciting to join you today at NXP Semiconductors in Chandler, Arizona. And as the mayor of Chandler, I'm thrilled that such an innovative company to open a brand new gallium nitride technology fab. Chandler is a community of innovation, and the city is an ideal location for industry leaders to engineer, test, and manufacture new technologies that provide innovative solutions to improve our quality of life. Recently, the City of Chandler celebrated the National Autonomous Vehicle Day by showcasing NXP as a major semiconductor supplier in the automotive industry. And with the emergence of 5G for cellular communications, supplying gallium nitride technology will also position NXP as a major semiconductor supplier in radio communication frequencies. Gallium nitride production in the USA and right here in Chandler, Arizona is something that I'm very proud of. It's very proud to witness what's happening in our city. Our city has been ranked as one of the best places to find a job, as one of the safest and most livable cities in the United States. We've been recognized as well as the innovation and technology hub of the Southwest, and it's all because of companies like NXP that are on the forefront of what's next. So I want to thank NXP for their continual investment in our community. Congratulations and good luck, and know that you have a partner in Chandler.
And now it's my pleasure to declare NXP's newest factory open for business.
Hi, this is Governor Doug Ducey. It's my pleasure to join everyone on this big day for NXP Semiconductors and our entire state. Arizona is proud to be a place where the world's foremost innovators come to make their mark on the world. Arizona is a national leader in the manufacturing of semiconductor products, with $3.5 billion worth of exports from this industry in 2019 alone. Arizona is also known as a state that has paved the way for the development of next-generation technologies, including 5G. That's what makes today's event so exciting. With NXP's new state-of-the-art fab in Chandler, Arizona is set to grow its reputation as a tech manufacturing powerhouse and a pioneer in 5G innovation. To the incredible team at NXP, we know you had many options for where to grow your business. So thank you for your continued investment in the state of Arizona. We look forward to witnessing the many ways your work here will power and transform how our world communicates. Congratulations, and we wish you nothing but immense success in the months and years ahead. Thank you.
Congratulations, NXP, on your new Chandler facility. Today, we celebrate your leadership and continued innovation in the semiconductor industry. Arizona leads the way in innovation, and we are proud to have you all call the great state 48 your home. Earlier this year, I was proud to support NXP's work by introducing the Bipartisan CHIPS Act and helping solidify America as the leader in semiconductor manufacturing. I look forward to celebrating your work and partnering to create opportunity and jobs in Arizona.
Hi everyone, Senator Martha McSally here. It's an honor to join you virtually for this important day for Arizona and our country. Congratulations to NXP for opening this new manufacturing facility for gallium nitride in Chandler. With the emergence of 5G for cellular communications, supplying gallium nitride technology will well position both our state and our country for greater high-tech innovation. I've long advocated to bring key manufacturing and technology innovation like this home to America, so we aren't relying on adversaries like China to produce materials that are critical to our national security. Today's announcement by NXP brings us closer to that goal. I applaud the NXP engineering teams in Chandler for unveiling this new gallium nitride technology manufacturing line. Arizona is a great place to live and work, and I welcome this expansion by NXP in our amazing state.
On behalf of Secretary Ross and the Department of Commerce, I want to take this opportunity to welcome you to the official opening of the NXP's gallium nitride fab. I am honored to join the distinguished leaders from NXP, the City of Chandler, the great state of Arizona, and others to celebrate the opening of this magnificent semiconductor manufacturing facility. Your presence and participation in today's event is a strong and clear demonstration of support for NXP's investment in America, especially in an industry that is critical to innovation, technology, and the U.S. industrial base. As Acting Undersecretary of Commerce for International Trade, I have the distinct privilege of leading the International Trade Administration, or ITA. For those of you who are unfamiliar with ITA, a major part of our mission is to promote trade and investment. Thanks in large part to President Trump and his administration's pro-growth, pro-America agenda, we have placed a high priority on encouraging foreign investment in the United States. This is reflected by today's official opening of NXP's new gallium nitride semiconductor fab, which is yet another example of President Trump making the United States the most preeminent destination for foreign direct investment. NXP is an impressive company employing nearly 31,000 people and operating in 33 countries with more than 100 facilities around the globe. The United States could not be more honored that NXP chose to build its latest and most advanced fab here, representing its second fab in Arizona and its fourth in the United States. This is a clear sign that NXP is committed to the United States and has found good reasons to invest right here. Overall, NXP invested $100 million in the new gallium nitride fab, which will employ an additional 250 highly skilled U.S. workers. Furthermore, this is the largest 150 millimeter gallium nitride fab in the entire world, and it will be able to supply half of the global market for gallium nitride semiconductors by the end of 2021. The microchips built in this facility and across Arizona are critical components that will help U.S. mobile operators and carriers deploy advanced 5G cell towers, base stations, and other 5G infrastructure around the United States and the world. This new facility represents a significant contribution to U.S. efforts centered not only on building a homegrown 5G infrastructure supply chain, but also to strengthen our U.S.-based semiconductor manufacturing capacity. As we move forward, we appreciate our expanding partnership with NXP and with all semiconductor companies that value open markets, strong IP protection, and fair competition. I want to thank Kurt Sievers, NXP President and CEO, for NXP's continued investment and support of the United States, and I look forward to seeing how our relationship continues to grow and thrive over the coming years. With that said, thank you, and congratulations on the opening of NXP's new gallium nitride fab. Thank you.
Digital technology connects all of us. It is the key to innovations in transportation, in healthcare, and much more. Every aspect of modern life, in fact. Digital technology makes it easy to pay our bills, to talk face-to-face with family, and to bridge vast distances to work with colleagues from the comfort of our homes or in offices on separate continents. In these challenging times, the pivotal role of digital technology is more evident than ever. NXP Semiconductors, a Dutch company that operates globally and has its roots in Philips, has always been in the forefront of these developments. For example, by producing chips in the automotive and security fields. Now in the 5G era, NXP continues on the forefront here in Arizona, a great example of the economic ties between the United States and the Netherlands. And that is why I'm very pleased to join NXP as it embarks on a new manufacturing facility for gallium nitride technology. This technology is key to develop 5G. As the ambassador of the Kingdom of the Netherlands to the United States, we are watching the future unfold with the increasing demand for connectivity. 5G will provide the backbone to make this future possible for all of us. And it is a great accomplishment for NXP to take this next step in producing leading-edge products that are critical to build this advanced 5G network. An important bonus of this technology is that it also greatly reduces the use of energy. This is a great investment that will help strengthen the semiconductor industry. Cheers to NXP at this celebration. I look forward to continue working with you. Congratulations.
Hello and welcome. My name is GENO FALLICO and I'm NXP's GaN Fab Manager. Today, we're going to give you a small taste of what it's like inside our factory. So let's step inside. We are now in the clean room. The air in here is completely changed over 350 times per hour, and that helps filter out particles that could damage our wafers. To keep it clean, there's a strict entry protocol, and we all wear our bunny suits while inside. Here's one of my colleagues now. Working all day like that can certainly take some getting used to, but it's absolutely critical for the quality of our product. While we're a compound semiconductor fab making GaN on silicon carbide, there's a lot in common with well-known silicon factories. If you're familiar with these fabs, you'll recognize a lot of the equipment. Photo, etch, here's a deposition tool, cleans, and all of these have significant automation. This overlap really allowed us to leverage the full power of NXP's manufacturing know-how. However, there is one clear difference between us and silicon fabs: transparent substrates. Typical robots just can't see these wafers, and this was one of the critical challenges that we had to overcome early on. As we continue our tour, we're now in one of our etch and cleans bays. It's within these bays that wafers are tracked in and loaded into the equipment. However, most of the actual processing is done within the tools behind the bay walls, in what we call the chase. And this is where the semiconductor magic really happens. So let's go take a look. Here we are in the chase. You can see that to make these tools work, there are many components that do not touch the wafers. There are pumps, chillers, abatement units, RF generators, gas and chemical delivery systems, and these big stainless steel pipes overhead are our acid exhaust. Significant infrastructure is needed. This isn't something where you can simply order a tool, plug it in, and just start running. To monitor all this complex equipment, we leverage many NXP-wide quality systems and tools to ensure the highest quality product. Automated SPC, real-time fault detection, and many more that really leverage the massive amounts of data that we generate every day. Our exceptional team works 24/7 to safely deliver high-quality GaN product and delight our customers. We thank you for joining us for a peek behind the curtain.
Hello, my name is GENO FALLICO, NXP's gallium nitride fab manager. I was working in NXP's automotive factory in Austin, Texas. I was the device integration manager, and my boss at the time came up and said, hey, there's an outstanding role in Chandler, Arizona. Are you interested in this? And that was on a Monday, and went through interviews that week, and really by the end of the week, found out I had the role, and on Monday I had an opportunity to meet my new team. So it was a real whirlwind, and it hasn't slowed down at all since. Building a team, that was our first challenge. We're fortunate, we had an outstanding team here locally in Chandler, Arizona, an existing team within the company. And we chose that team really because of the existing compound semiconductor experience. And we leveraged that experience and expanded significantly from there, doubling the team within the year. We expanded locally here in Chandler. Of course, we also leveraged our automotive factory right next door here on site to bring in a really strong process experience and the total quality mindset. Our second challenge was really the fab space and the equipment set. We had to build the factory and expand the equipment, and we had to define the process flow. So we had to make sure that the equipment set was flexible enough for high volume manufacturing and scalability, as well as expandable beyond 5G. Of course, that equipment didn't actually come as we ordered it, all in the order that we would have liked. So we were unable to, our initial lots, we essentially had to process without some of that equipment and get very creative. But even given that the incomplete equipment set at the beginning, our first lots yielded pretty well and were pretty close to the specifications, which is a real testament to the RF's team's experience and knowledge of the integration and the GaN flow, as well as the process team's processing experience and knowledge there. We were on the leading edge of 6-inch GaN on silicon carbide, and that presented many challenges. We had initial supply and quality issues that we were struggling to get enough wafers. We worked through those, but there were also vendor challenges with some of the equipment that weren't ready for 6-inch silicon carbide processing. So we really had to work closely with our vendors and co-develop equipment. We had outstanding results on our initial samples, but building a factory is not about a couple of samples. We really needed to make millions of devices. And so we needed to build in quality from the very beginning. We really had a benefit having the NXP know-how, manufacturing know-how in particular, behind us. We're now the 6th internal fab in NXP, and that gave us a lot of knowledge to tap into as we went through that. Not only on the resource and processing side, but from a systems standpoint, we have outstanding quality systems, automated SBC and fault detection, and really the ability to leverage big data through machine learning and AI that really helps us identify issues real time. Here, Arizona has been fantastic to me, and really there's so much to do in the factory. We're developing the next 2 technology nodes already. We're working on continuing to scale up the factory and delighting customers. So no plans to move from here, and Arizona's really grown on me. The snowboarding and close by and all of the other wonderful things here in the area, and really it's just a dry heat.
Hi, today we'll talk about GaN. Joining me are some of our designers and applications engineers sharing their first impressions working with GaN. Let's get started.
I remember looking at the data for a GaN device for the first time, and there's just this overall feeling that we're truly entering into an exciting new era in terms of device technology.
My first impression working with GaN is that it's a lot like driving a race car. It's fast, it's exciting, it's even dangerous if you bias it up the wrong way. I'm glad the future is finally here, and I thank the team that made this possible.
So yeah, the first time I used GaN parts, I was actually in the lab tuning LDMOS parts, and I threw the GaN parts on, and I thought the current meter was broken because the efficiency was so high. And that was a couple years ago, so I'm pretty excited about our own process, because everyone knows home cooking is always better.
When I first looked at this GaN technology, I had to be aware of the bias sequence and monitor the dissipated power. But after I started tuning, I thought, wow, this really makes software-defined radio possible. And it's a really rugged technology.
The first time I worked with it was in the lab tuning it. And right away, I see the performance being really promising. And I now understand what the hype is from all over the world sorting for GaN solutions.
I can remember my first time working with GaN a few years ago. I couldn't believe how much bandwidth we could get out of one single device in one single applications fixture. It was like going from a 1-lane road to an 8-lane highway.
I started working on GaN about 3.5 years ago. I was tuning a fixture in the lab, and I remember my first impression was about how small the package is compared to the amount of power we get out of it. I guess as they say, great things can be small packages.
When I first got my hands on GaN Echo devices, I thought to myself, what an amazing opportunity we have to now be able to design, build, test and sample our customers faster than ever before with market-leading technology and products.
Low memory GAN, GAN, grown at NXP.
Hi, I'm Bob Salsky, the Quality Director for the Radio Products business based here in Chandler. Today I'm going to talk about quality as it pertains to our products and to the GaN fab here in Chandler. At NXP, we're committed to being the finest semiconductor company in the world, producing the highest levels of product quality and services as viewed through the eyes of our customer. So why is total quality important to NXP? In a 5G world where increasing numbers of users and data connections are demanding more from our network communications infrastructure, reliability is essential. Every communication, bank transaction, data connection, even a video call between parent and child is important and expected to happen flawlessly. Imagine a world where 1% of your bank transactions failed. I don't think you want to imagine that. Or if your calls are frequently disrupted. Any disruption to communications have drastic consequences and is very important for all of our users, and especially in light of a more connected world. Therefore, customers demand high quality in our products and our services to maintain a reliable network. Our relentless pursuit of total quality in the Chandler GaN fab is fundamental in ensuring we have a smart, secure, connected world. NXP is passionate in our relentless pursuit of total customer loyalty by instilling a high-quality culture resulting in manufacturing excellence and flawless new product introduction. So when our customers think of NXP, we want them to think total quality. First time right implies flawless new technology, new product development, world-class manufacturing process like those here in Chandler, in our GaN fab, and are designed to deliver zero defects to our customers. Should issues arise, we do have world-class customer support to resolve their problems. All of this enables a total mindset and quality culture. The cornerstones of total quality are not only manufacturing and leadership, development and participation of our employees in an environment where they feel empowered to stop, fix, and report problems. We've established standard ways of working with strong compliance culture. Additionally, development of effective processes and costs and lessons learned. At NXP, we demonstrate our commitment to manufacturing excellence by achieving the most demanding standards for international quality. All our operations worldwide, including the GaN fab here, is held to an automotive standard, whether they ship automotive products or not, and verified by a third-party auditor. NXP has invested $190 million in recent years targeted towards zero defects. Our IT systems are capable of traceability from front end to back end. They provide capability for advanced statistical process controls to achieve higher yields and more consistent product performance. These systems and our manufacturing operations enable high quality levels for NXP RF GaN products. Total quality places a strong emphasis on prevention through risk assessments, FMEAs, and effective root cause problem solving, and fan out of these lessons learned. And finally, total quality is a mindset that prevents problems in manufacturing operations and our other processes. People are empowered and encouraged to stop and fix. So in closing, the investment in the Chandler GaN fab and NXP's GaN technology is important for our radio products business and the 5G market moving forward. Our total quality culture and mindset enables NXP to achieve higher quality levels in performance and reliability. Thank you for watching. For more information, please visit nxp.com/RFGaN.
And now I'd like to introduce our Chief Technology Officer, Lars Rieger in Hamburg. Lars?
Hi, Paul. Big thanks for the kind words, and to you and the team, big congratulations. As Kurt said prior, I'd wish that I could be with you in sunny Chandler in spite of staying here in rainy Hamburg and celebrate this very, very special day with you. The opening of, as I guess, the best GaN fab on the planet. I'm super excited because this is also portfolio-wise and technology-wise for us, for NXP, a huge quantum leap. It's a great milestone to achieve. The GaN products in 5G will be the next booster for 5G rollout, not only by the efficiency, but also by data rate, frequency band. So truly, truly instrumental to seeing GaN products driving the 5G adoption in the infrastructure. So with that, adding to our NXP portfolio, having a great new industrial footprint, having such a great capability for connecting the world in our hands is, of course, a fantastic topic. Plus, what I think we can bring to the industry is we can look into our toolbox and take, for example, automotive ways of approaching quality, our advanced ways of designing products and simulating, all into the capabilities of our GaN products. And with that, I hope that we really move the needle in the market. All the best to you and the team. I hope I can be, as soon as COVID lets me, with you in Chandler and real time in analog on the ground, celebrate the GaN fab opening with you. Until then, all the best. Enjoy this day. And again, big congratulations from my side.
Hello, I'm Sherry SCHUMM, the IP creation lead for the radio power business. Many of you have been part of the historical development of NXP's power transistor product portfolio. Recently, we're able to celebrate the 25th anniversary of the first product qualification for the LDMOS transistor. A disruptive technology at the time, the LDMOS transistor rapidly became the gold standard in power transistors for cellular base station transmitters. You may know that the first patent for the LDMOS transistor was granted nearly 30 years ago to inventors right here in Arizona. Since that first LDMOS patent was granted to a portion of Motorola that's now NXP, our exceptionally talented team of RF power engineers have continued to patent the groundbreaking technologies associated with new LDMOS designs and fabrication methods. More recently, with the emergence of 5G cellular infrastructure and its higher power and operational frequency requirements, gallium nitride power transistors have begun to emerge as the new potential gold standard for cellular base station transmitters. The new GaN fab in Chandler is a highly visible demonstration of NXP's commitment to this technology. However, that commitment is not new. For many years, NXP has been pursuing intellectual property protection for advanced GaN transistor device structures and associated fabrication methods. With GaN transistors poised to take a front seat in cellular infrastructure deployments, NXP has accelerated its GaN development, and along with it, our pursuit of innovations created in the context of this development. NXP's well-oiled invention submission and patent protection apparatus, coupled with well-trained technical and legal teams, enable us to continue to build a robust IP portfolio to protect new GaN-related inventions. NXP's IP in the GaN space covers inventions intended to optimize GaN device performance, reliability, cost, and size. More specifically, NXP's GaN IP portfolio protects inventions associated with GaN devices that have increasingly higher gain, efficiency, and power density, all the while exhibiting excellent linearity. With the proximity of the GaN fab to NXP's radio power group in Chandler, engineers may more rapidly develop, implement, and validate inventions for current and future generations of NXP GaN devices. This in turn yields shorter cycle times for developing and protecting our GaN-related innovations. For more information regarding NXP's IP protection processes, please contact the NXP legal team.
Hello, my name is Suhail Abwani. I'm responsible for high-power solutions product management for NXP RF. I'm joined here today by my colleague, Eric WESTBERG, who is the product line manager for Integrated Product Solutions portfolio. Hi, Eric.
Hi, Suhail. It's nice to be with you here today, at least virtually, and thank you all for joining us online. We are excited to share with you an update on the 5G market and the technologies that are enabling the global ramp of this new cellular infrastructure generation. Specifically, how gallium nitride on silicon carbide, or GaN for short, is coming into its own and enabling this new market. But first, a little history on cellular infrastructure generations. We're talking about the technologies that enable the cell phone towers you see as you drive up and down the expressways. Today, we're talking to you here from Arizona, where we have a different way to hide these antennas, sometimes more successfully than others. Most of our cell phones and other devices today operate on a 4G network. The access part of the network is primarily built through traditional macro base stations. This often consists of the passive antennas on the tower, powered by the electronics in a building at the base. And as we look towards the future, 5G intends to improve on the 4G network in 3 key ways. First, an increase in data throughput. Second, a reduction in latency. And third, by enabling many, many more connected devices. To meet these new improved capabilities, there are several new base station architectures being deployed, include enhanced macro base stations and remote radio heads, small cells, and a new generation of systems referred to as active antenna solutions or massive MIMO systems. There's also new frequencies being used across the globe for 5G. But really, to enable this success of 5G deployments, this new generation of cellular infrastructure technologies needs to be smaller, lighter, and much more power efficient.
Yes, Eric. In fact, to allow for an even quicker adoption of 5G than previous generations, the base station industry has needed to look for new architectures and technologies that not only enable faster networks, but also deliver improved energy consumption, which, as we know, is environmentally responsible and at the same time also lowers the cost of running the networks for the operators. Now, for many years, gallium nitride has offered the promise of high performance, and even though GaN has been in use in the aerospace and defense segments for quite some time now, the technology had not yet reached the level of maturity needed for consumer-driven markets. The high power densities of GaN and energy efficiency has always been seen as a key to compact radios. And now with 5G upon us, we not only need smaller and lighter radios, but also many more in numbers than were ever needed in previous deployments. And of course, as you said, spectrum expansion means that the range of frequencies used for transmission continues to grow as well. So this is really great timing for GaN, where the market forces are aligned with technology availability. And to make it happen, NXP is ready to make this 5G transition a reality. We are so excited to be a part of this 5G revolution and look forward to continuing this conversation with you. Thank you again for joining us today.
Hey, hello there. This is an accelerated course about the history of RF power amplifiers and cellular infrastructure. First of all, please imagine with me this is a base station tower. In the old 3G days, the RF power amplifier was at the bottom of the tower next to the baseband. The antenna was at the top, but there were too many RF losses in the cable going from the bottom to the top, making it not very efficient. So coincidentally with 4G, we got rid of the power amplifier at the bottom and built a remote radio head where the PA is at the top of the mast next to the antenna. But all of this is big and heavy. Now with 5G comes GaN and its remarkable power density. So now we can replace this large chip with a much smaller one. Both chips deliver the same power. And compared to where we were at the beginning, this is almost 2 times smaller. Let me explain now what massive MIMO is. Here in this box is what we call 4T radios with 4 RF transistors. And here, 32T radios with 32 transistors. You're welcome to count. Sometimes it's even 64. The total power of the antenna remains the same, But the idea is that we replace high-power chips with many low-power ones, 8 times lower in this example. I'll let you do the math. As you can imagine, each of these tiny chips make up a PA lineup and a full transmit chain, and this new complexity is power hungry. That is why GaN comes into play. RF GaN transistors have an awesome efficiency. Thank you for watching.
Semiconductors used in Doherty power amplifiers are expected to be highly linear, stable over temperature, and extremely reliable. Gallium nitride on silicon carbide is the semiconductor of choice in today's 5G base station amplifiers due to its high power rated efficiency, linearity, and high reliability. Today's GaN technology for RF applications is built on a complex semiconductor material system that uses silicon carbide as the foundation substrate with aluminum gallium nitride epitaxy as the active device layer. However, for some time now, GaN on silicon carbide technology has been plagued with non-ideal behaviors related to defectivity. Defects can be located in the bulk of the semiconductor or at the surface at the interface of the semiconductor and dielectrics put down during the processing of the wafers. These defects cause electron traps that make it difficult for the transmitter system to compensate in both static and dynamic conditions. This is often referred to as having memory because the device behavior may depend on the operating point in time. For instance, amplifier gain or linearity may be a function of time or temperature. 5G TDD systems pose a unique challenge due to the dynamic behavior of the signal and strict linearity requirement. 5G transmitter systems are designed to compensate nonlinearities in the power amplifier like amplitude and phase distortion. Memory effect issues make it difficult for pre-distortion systems to reduce or eliminate nonlinearities to manageable levels. NXP has a long history working with compound semiconductors like gallium nitride, stemming from when we were Motorola Semiconductor Products Sector and we had our own gallium arsenide wafer fab. It was here that NXP began its own GaN on silicon carbide technology development. This development focused on process development to ensure a robust surface passivation and proprietary low memory epitaxial structure to realize high RF efficiency, high breakdown, and controlled RF transient and dispersion, giving way to extremely stable RF power from static through to transient conditions. NXP's low memory GaN technology is perfect for 5G new radio TDD signals and delivers best-in-class power rated efficiency and reliability. 5G isn't just coming, it's here, and NXP's GaN technology is ready to meet the demands of this high-speed communication platform. For more information, please visit nxp.com/RFGaN.
This is NXP's 101 course about GaN memory effect. For the sake of the demonstration, please imagine with me that this is an electron in the gallium nitride semiconductor. GaN is a fantastic technology, but standard GaN has a known issue. It has a memory. And this high memory effect makes it very hard to get a linear response of the RF amplification, even using the most advanced pre-distortion systems. Let me explain. In standard GaN, electron gets trapped. Then only later it gets released. This creates, for instance, a delayed response of the drain current with respect to the drain voltage variation. But NXP has deeply optimized the GaN epitaxy for RF power amplification to create a low memory GaN. A GaN that does not have a memory of where the electrons are. A GaN that does not trap electron, enabling a faster, linear response. And voila, there you have it. Thank you for watching.
Hi, I'm Justin Annis, Applications Manager for NXP's Radio Power team. I'll demonstrate to you our characterization of NXP GaN for 5G in the lab. Let's take a closer look. Today's cell towers have changed quite a bit over the years. They've gone from lower antenna count to higher antenna count. This higher antenna count brings you faster and clearer signals. 5G radios have up to 64 antenna elements, each one containing a power amplifier module such as this one here. To test NXP's GaN, we have to recreate the 5G radio setup in our lab. We use a signal generator to generate a 10 by 20 or 2 by 100 megahertz waveform. We send this to the PA and then out to a signal analyzer. The two main things that we're looking for are signal integrity, aka error vector magnitude, and how much energy is leaking into the adjacent channels, or adjacent power ratio. Let's go to the lab and take a look. So we're now in the lab to look at the adjacent channel power. We have our signal source, which is 10 by 20 megahertz LTE waveform, and we're going into a preamp and then into our RF GaN module. Alright, so here's a raw uncorrected spectrum of the signal. In the center of the image are the 10 transmit carriers carrying the data, and then on either side are the adjacent unused channels. Currently, the delta between these two is about 33 dB. Now we're going to linearize the PA. So as the linearization is applied to the PA, you can actually see the energy in the adjacent channels decreasing. Our goal is to reach 50 dB delta. Let's see if we can make it. And done. Yay! Now that we've taken a look at adjacent channel power in the lab, let's take a closer look at linearity, or the signal integrity of the power amplifier device. What we're showing here is EVM constellation map. The EVM represents the linearity, or how faithfully the signal is being reproduced by the PA. On the left, we have traditional GaN, which you can see has a very cloudy and dispersive point pattern. This means that the PA is distorting the signal beyond normal or what's accepted. On the right, we have our NXP RF GaN. You can see the data converging to a single location. This means that we're faithfully reproducing the waveform and making sure that the 5G signal is getting to you. Back live from the bench, here's traditional GaN linearity, and then the excellent linearity of NXP's new RF GaN. We're very excited to get our NXP GaN technology into your hands and in your lab for you to test yourself. Thank you very much for watching, and please stay tuned for our products coming out soon.
Every day our world is getting smarter, faster, and more connected. For more than 60 years, NXP has pioneered the ideas that have propelled us forward. The Radio Power Group of NXP continues to lead us towards the future through innovation in the most advanced technologies for a world with insatiable demand for information. Today, we are joined by a panel of industry experts to talk about the next breakthrough in cellular communications, 5G. There are 4 panelists with me today. We'll virtually go around the room so each person can introduce themselves, starting with Dan.
Hi, everyone. It's a pleasure to be here today. I'm Dan McNamara, Principal Analyst at Mobile Experts. My primary areas of research are base station infrastructure and then the semiconductor content in both base stations and cellular handsets. In my experience, really my entire career has been in the RF world, either as a designer, or applications, or marketing or business development. So it's an exciting time to be doing this work. Thanks.
Hi, I'm Tom Watson. I'm the director of the IWPC. For those of you that aren't familiar with us, we're an industry association. There's about 150 odd companies globally that are members. And in normal times, we put together technical workshops around the world on topics largely driven by the carriers that are interesting for the industry. And I've been in the industry about 20 years, and I've done a startup, which brought me here to IWPC and tunable RF components for handsets.
Hi, my name is Jim Norling. I'm the Vice President and General Manager of the High Power Solutions product line within Radio Power at NXP. I've got about nearly 30 years, all in RF. And the High Power Solutions is really the high power discrete and IC solutions, primarily for communication systems.
Thank you, Jim. My name is Pierre Peel, and I'm the Vice President and General Manager of the Integrated Power Solution product line at NXP. And I've been in RF power for the past 20 years in functions from design to product management. My focus today, the focus of my product line, is massive MIMO integrated modules, 50 ohm in and out, serving the 5G massive MIMO market.
Great. Thanks, everyone. So let's get started. So there's so much buzz around 5G these days. In what ways do you think 5G will be evolutionary, and how will it be revolutionary in terms of user experiences?
Maybe let me start. So, 5G is a super exciting time, and part of that excitement, I think, is it's still really all in front of us. We're really at the beginning times of what 5G is going to be doing. And with all the prior generations, we've definitely had this expectation that things are going to get better every time, and I think they have. And 5G is going to be no different. But it's going to be more profound, I think, in ways that people don't really expect. And if you take a step back, you think about the 2G world. People are so excited that they could put a phone in their hand that wasn't connected into the wall. And then 3G came along, and hey, it does more than voice and text. That's pretty cool. And then 4G, where we are today, lots of data, lots of videos, all these awesome things that you can do with your smartphones and other connected devices. It's really incredible. And 5G is going to be a lot like that. And it's really enabled by 4G. 4G really set the table. It's the baseline that's going to get used for all the 5G networks. In fact, the 5G that rolled out last year in 2019 and even still today is linked to 4G. So it's called non-standalone. You have the 5G network in conjunction with 4G. And so you're getting a lot of these benefits already, even in a sort of a partial implementation of 5G. And so now the other thing I wanted to mention is 5G will have not only the massive increase in speed and data from smartphones, it's also going to have other aspects to it, like this massive IoT, where there's going to be millions and billions, really, of connected things to the network. And then furthermore, there's going to be this low latency network that exists that's really going to help businesses. You're going to have these automated factories where you're going to have robots running around and massive data being collected. But now you have the ability to process and feedback results almost instantaneously. That's something that really hasn't happened before. And other applications of that are going to look like telemedicine, which is happening today, and even gaming. So there's a lot of really exciting and different things happening with the 5G network.
And I can jump in here. As far as evolutionary versus revolutionary, I think it's fair to say that new radio is more of an evolution of 4G. It's still a OFDM-based system, but that has wider bandwidths, and they did quite a lot to improve signaling and frame structure and these sort of things, which will all help to improve the throughput of the devices. But really, I think from an operator's perspective, given their need to cut costs and find new sources of revenue, a lot of the core network functionality is really going to be important. Things like network automation from a cost-cutting point of view, so you don't have to scale the number of people as you scale your network to manage it. Things like network slicing is going to give them the ability to provision services and offer new services on the fly, all with an eye towards going after new sources of revenue and new business opportunities. Some of the things that I've seen quite a lot of interest in over the last couple of years, private networks, V2X, vehicle connectivity, What kind of support can mobile networks offer for autonomous vehicles, manufacturing, mining, logistics, etc.? All these sort of things are, I think, ripe for 5G to bring these new capabilities to bear.
We know that many operators who already have their 5G networks running and others that are in the process. Dan, what is the current state of deployments and what is your forecast for 5G ramp next year and beyond?
Yeah, sure. It's really moving quickly, and so 5G as a build out, when people talk about it, it's really quite complex, and there's a couple of different things going on. And so I wanted to focus really on sort of the two really different frequency bands where 5G networks are being built. There's the sub 6 gigahertz side, and there's the millimeter wave side. And so the sub 6 is where the majority of work is happening, and millimeter wave is still more in its infancy, and I'll only talk a little bit about that. So specifically about C-band, so this sub 6 gigahertz work, 3.5 gigahertz, a little bit in 2 gigahertz, depends on the region. It's an amazing amount of activity going on right now. And some good examples are what's happening in Korea, what's happening in China. Korea specifically, in the first year of 5G deployment, the 3 operators in Korea, they basically achieved full population coverage in less than 12 months. That's really impressive. And they continue to densify their network. And in fact, they're going to go into the next step. And I talked before about having this combination of 4G and 5G as non-standalone. Korea is going to push ahead with what they call standalone, where you have a network which is just connected to 5G systems, 5G base stations, 5G core. And that's really going to have enhanced improvements, even more than what we even talked about, what you can get with the current networks. And then you have what's going on in China, which by any metric is just astounding as far as the amount of material that's being consumed. Really, in 2020, 80% of all 5G base stations globally are going to be deployed in China. It's a huge percentage. And this is going to continue. I mean, the rest of the world, of course, is also doing 5G, and you hear about it every day in different countries in Europe and Asia and Africa. But the combination of everyone else, their work and their volumes will match China probably in 2 years. It just tells you the scale of what's going on in the China network. It's pretty amazing. And maybe if I can, just a consequence of this massive build out is really having a positive impact on the supply chain, and specifically on RF semiconductors. And this is really a result of the fact that in 5G, there's going to be this concept of massive MIMO. And maybe at a simplest level, in LTE, you had 4 transmitters per radio up on the cell tower. But in 5G, with this massive MIMO, there could be 32 antenna elements or 64 antenna elements. So okay, that sounds like a lot, but the real implication here is 1 PA per antenna element. So in LTE world, there was 4 PAs used. Now in 5G, it's 32 or 64. So that's just a huge increase in PA content that has to be supported. And just some rough numbers, in LTE days, maybe 2017, 2018, we're talking about 30 million, perhaps, output devices per year being shipped globally to support LTE systems. 5G, in a couple of years, it's going to be 350 million output stages. So more than 10x. It's a huge increase. And so the market really has to step up and increase its supply. And the other thing I wanted to say about the power amplifiers is we have a new technology now in the mix. Prior, all generations, 2G, 3G, 4G, there were LDMOS. LDMOS is very mature. It's been used for many, many years. There's a new technology called GaN, gallium nitride, which is going to offer improved performance, specifically in the area of power added efficiency. And in fact, I expect the number of GaN PAs will probably be about half the market next year. And by 2024, it could be almost 3/4 of the market as far as the types of PAs shipped into the market. So it's very impressive, very rapid growth. So that's actually pretty exciting for PA suppliers. And then really the other part of the market that I was going to touch on was millimeter wave. And really it's not as big a market as far as how many deployments are going on right now. It's actually being led by the US. There's more work done in the US right now than anywhere else in the world. And it's primarily being done by Verizon. So Verizon's going to take this technology. Millimeter wave signals don't travel as far from the base station. I think people understand that, but it has huge bandwidth. So it's a complementary piece to the whole 5G solution, where there's going to be millimeter waves in high, dense urban areas, lots of data being consumed. And then the US, when it deploys its C-band network in 2021, will then have this combination of millimeter wave and C-band, which will be the optimal solution for a 5G network.
Thanks, Dan. I appreciate the market details. So Tom, from a technology point of view, what are the essential building blocks needed to unlock the full potential of 5G?
Well, again, let's reiterate just sort of from an operator's perspective and why they would spend money on deploying 5G is, every operator in the world is basically in the same situation where they have declining revenue per customer and they're having to provide more and more services. So there's a real need to cut costs and also find a new source of revenue opportunities. And so that's all started in 4G and it'll continue and accelerate in 5G. One example would be the densification of the networks that we're seeing now. Quite a lot of small cells, particularly here in the US, a lot of fiber being put down now, and a lot of that with an eye towards accelerating 5G when they're ready to actually deploy those radios, that the infrastructure will, in a lot of cases, already be in place. So there's going to be more cell sites, maybe not more macros necessarily, but probably antenna swapping out, massive MIMO, those types of things. But a lot more small cells look like they're finally going to be deployed. And higher order, as Dan had already addressed, the number of components that are required to build these things when you go from 4T or 8T to 32 or 64, obviously going to have a lot more RF content. And one of the things that's bringing with it is a problem, both on the digital and the analog side, is power consumption and heat dissipation in these massive MIMO systems. It's a real issue, and everybody's looking for a way to get these things addressed. And now you look at another trend that's continuing is the power. And each of these radios continues to, go higher and higher and higher. It started out at a couple watts, now it's 20. They're even talking, I think, upwards of 60 watts per radio on these things. So that's going to just compound this same issue that the manufacturers have and the carriers, frankly. The power consumption and the cost, such a huge part of every operator's budget that needs to be addressed. So any improvements in semiconductors that can address these challenges, I think, would be most welcome.
Thanks, Tom. So you mentioned that higher order MIMO is one aspect of 5G infrastructure. Jim, what technologies are needed to ensure the best network performances?
Well, I think Dan and Tom both touched on really the couple of the different choices that are available. There's, for the radio, the RF power portion of the radio, there's really primarily two. That's LDMOS, as was mentioned. That's silicon-based technology, and that's been around for 30 years now. It's a highly reliable, cost-effective solution, and has really been the choice of most OEMs, from really analog systems all the way to where we are in 4G today. But with any technology, there's trade-offs, and with these new systems coming on, that and as you can imagine, you go from the 4 transmit or the 2 transmit, 4 transmit, or even some 8 transmit systems to all of a sudden these 32 transmit systems or 64 transmit systems with RF paths for each. You can imagine the size and weight and power consumption really becomes a critical aspect that needs to be looked at. And that's where really gallium nitride comes into play. It does have inherent advantages over LDMOS, where that fits really nicely in those higher order systems. Clearly, that was, as was mentioned on the power consumption side, the higher power out efficiency reduces that power consumption, and it was, as was mentioned, is a really a cost adder for the operators as they operate their networks. But the other side of things, or another aspect of GaN, is the power density. Basically, that means the amount of power you get for the same area of die is larger for gallium nitride. So that allows you to shrink down the equipment. This equipment resides at the top of a cell tower. That real estate, for lack of a better term, in most cases you're renting that. So the smaller the radio up there, the better for an operator. So that's clearly another advantage that GaN provides. And as you shrink that from a size, also the weight is another thing that needs to be considered. So all of those things combined really point towards now gallium nitride being a leading technology as we move into the 5G arena here. And certainly those advantages will come to play. Now, the only, reducing those systems costs for the operators by using GaN is just one aspect of getting the cost out. Now, there's clearly other things that need to be looked at, and one of those is further integration of the semiconductor components that are utilized in a radio. The more that you can add functions onto single devices, of course, that adds to performance, adds to size and weight, and certainly will reduce system cost quite a bit.
Thanks, Jim. I'm glad you mentioned integration as an important part of 5G radios. For Pierre, could you explain a little bit more about why this is so important?
Yeah, thank you. Dan and Tom went through the increased complexity of the 5G networks with domination of 32 and 64T systems. What that means for us as semiconductor vendor means that we still need to strive for the highest efficiency possible. And that has an impact on the overall system cost. And the opening of our fab here in Chandler this month is part and parcel to that strategy of delivering the highest performance to the market. But another aspect of that is that if you want to look at the overall system cost of those 64T systems, a very good way to reduce that cost is to integrate more and more functionality on our product, in our products. And so with that in mind, we developed a full portfolio of integrated modules, 50 ohm in and out, that also have an added benefit for a lot of our customers is that along with the complexity of higher order systems, there is also a multiplication of power and frequencies that are used for the deployments around the world. And the use of those integrated solutions means that for someone who's designing a system, they can have a fully drop-in solution that works across frequency and power that they can use in all of their systems. So that brings a lot of benefits in terms of time of development and time to market for the OEMs that use our products.
Thanks, Pierre. So we've heard a bit about what 5G is and some of the technologies required to make it a success. Jim and Pierre, can you explain why NXP is positioned well to support this?
Maybe I'll start and then I'll hand over to Pierre. I think the first thing is important to mention is the history in the market for NXP. We've been serving this market for 30 plus years. We've been a clear leader in this space for that entire time. As I said prior with LDMOS and now moving into gallium nitride. And even though gallium nitride is really now just emerging because of its inherent advantages over silicon, it's also worth noting that NXP has been investing in gallium nitride for nearly 20 years. That started with, for those that have been along in the industry long enough, remember the CS1 fab, Compound Semiconductor 1 fab, which at the time was the world's largest compound semiconductor fab. We started our investment in gallium nitride way back then. So we've got a lot of history, a lot of experience with both those technologies. And the other advantage clearly that NXP will bring now is, as Pierre mentioned, is the opening of our new fab in Chandler. Certainly allows advantages of being able to control a lot of different things that maybe you might not necessarily be able to do if you weren't vertically integrated. Technology development, of course, is a big part of that. And also, being able to control cost reduction is going to be a huge focus, will continue to be a huge focus, and that's what our customers and their customers are really looking for. So we were able to control that aspect better as well. And certainly, as everybody knows, this market is highly dynamic. It goes through swings up and down. We're in a huge up one right now, and having the ability to really react to those market swings is something that we pride ourselves on as well. So, another advantage that I think NXP brings as well. Just back to the technology development, we have IP that specific to the gallium nitride technology that gives us quite an advantage in the market. Maybe I'll hand over to Pierre to maybe expound on that a little bit.
Mm-hmm. Well, thank you, Jim. So absolutely agree. For all the reasons that we went through in this webinar, the investment that we have in gallium nitride is paramount, driven by the benefits in power rated efficiency. But if you look at the full system design, you need that power rated efficiency. But at NXP, we have had a continuous investment in LDMOS, in silicon germanium, and combining those technologies inside one integrated module that's going to not only focus on the TX performance, but include functionality of bias controls, of increased efficiency at the system level, will bring benefits in terms of compactness of the solution, enable cost saving in terms of the cooling requirements for those systems. And that's what an integrated solution delivers to the market. A combination of IP that we own at the GaN level, but as well in LDMOS, in silicon germanium, and in the overall architecture and design of the PA module. And with that type of integrated solution, we deliver maximum value to the market.
Great. So we've heard the perspective from NXP. Dan and Tom, what is your view on how NXP is positioned in this exciting market?
Well, certainly, as mentioned, it's really a great circumstance to be able to enter this new 5G market from a position of strength. And so NXP, we model the market as well, and fully agree that NXP is the leader in the PAs for the markets, and started in LDMOS and is continuing. And that provides a real benefit of having established customer relationships, especially when you're trying to introduce new technologies, because customers really want the best performance, but they want low risk. And so one of the ways you can offer that is by having that established relationship to work with people. So I think that's a real benefit that NXP can bring to its customers and to the market. And as mentioned, GaN is still relatively new. So there's still, I think, a lot of work to be done to get cost out, to improve the performance even further from where it is today. But that's hard work that can be done. So it looks like all the pieces are falling into place, and so it looks pretty positive.
Great. Well, I can't really add a whole lot to what Dan said, other than it must be a good market, because there's a lot of competitors are jumping in right now. So I think everybody is seeing the opportunity, and LDMOS is a pretty mature technology. I mean, any gains that you're going to make now are very incremental, whereas GaN is still, relatively speaking, in the fairly early days. And if you look at the gas market, for example, and how long that took to mature and how it continues to improve, I think that it's reasonable to expect that you're going to see similar types of and scales of improvements in GaN as time goes on. But at the end of the day, it's really going to depend on who has the ability to innovate and scale and deliver things at a cost-effective price.
There you have it, straight from the experts. I hope you enjoyed learning about the recent trends in cellular infrastructure and how GaN is impacting the 5G market. Thank you, Dan, Tom, Jim, and Pierre, for your time and insight.
Yeah, thanks very much.
Thank you. My pleasure.
Right.
Bye.
Thank you for joining us for the NXP RF GaN Fab grand opening ceremony. I hope you enjoyed learning about our GaN. If there was a session that you missed or one that you'd like to rewatch, please visit us at nxp.com/rfgan. For future product launches and announcements, please follow us on social media or visit us at nxp.com/rf. Thank you.